Hello? All right, well, today we are going to start the class that it is categorical data analysis. Let me share the screen with you guys. Okay. So, well, first, this is the categorical data analysis class. This is a 3-credit hour class. I am Luis Leon Novello. I'm going to talk about me a little bit. Well, the outline of the class is, well, learn how to analyze categorical data, the common use distributions in categorical data, that is binomial, multinomial, Poisson, a little bit of negative binomial, but not too much. Introduction to maximum likelihood. No, this is the wrong one. This is not what I wanted to start with. This one, right? Okay. So also, I need to share, I need to record the class. Oh. Okay. So let's start with the introduction to the class, right? So this is categorical data analysis class. So this course presents the theory and applications of categorical data analysis, categorical variables, variables that take discrete values. This is very common in public research, public health research or biology, right? Where you have responses that are 0, 1, like success, failure of the treatment, etc. And well, we will work with Stata for the people who took 1700. Stata is, they are familiar with the Stata. And also if you're familiar with R, that's awesome because I am way more familiar with R than with Stata. So we will work both. The textbook actually uses R more than Stata. But the procedures that we are going to learn in this class are so standard that it's very easy to find how to apply them to your data using Stata or R or SAS or any other software, right, to analyze data. So the learning objectives of the course is, well, to be able to handle and analyze categorical data. We need to learn how to use regression models. So for example, logistic regression, Poisson, and ordinal regression models. The main model that we are going to learn is the logistic regression model. We will talk about when it comes. Interpret the results, right, of the model. That is very important. Conditions of fit, etc. So our expectation of my expectation of you is that you read the announcement using Canvas. We will talk a little bit about Canvas too. That you attend class. We will always, or I will try to always store the class or save the class so you can see it later if you need to. But sometimes I forget, but well, you will have access to the video recordings of the classes, but you cannot ask questions, right, if you are not in the class. So it's always good that you attend the class, read the assignments and materials before the class whenever it's possible. Of course, timely completion of the assignments. We want the homeworks to be turned in on time. And well, you can use Canvas discussion boards, right? For administrative items you miss, homework questions, etc. So this is very important. This class may be for some of you very challenging, and well, I encourage you to work in teams. I know it is hard now with the setting that we have, but you can still work on Canvas. You can have discussion boards on Canvas. You can exchange forms. You can. I mean, whatever you need to work on teams, that helps, right? You can work on groups also to do the assignments. The only thing is that you are supposed to write your own report, right, of the assignment, right? So, and what you also have to do your own in exam class, or the format of the exam, of the midterm, we have only one midterm, it will be decided later, maybe proctor you. So this is the teaching team. So it's only one lecturer. Only one lecturer. It is me. I am Novello. That is my email account. But you can always. I think I prefer Canvas because if it is from Canvas, I know it's from the class. If you send it to my mailbox, I have so many mails, right? So you send to the Canvas. I think I will probably. It will take me less time to answer to your message, right? This is my office number, but well, right now you call me, I will just know that you call me and learn that somebody called me, but I'm not in my office for the pandemic, right? At least not right now. The teaching assistant, well, her name is So Xuan Lee. Well, she's also going to be online. Her office hours are Tuesdays and Thursdays from 10 a.m. to noon, and also on their appointment, right? And that's her email. But also, again, if you have questions, I think it's better to contact the TA through Canvas. So this is the way. Let me open this one. Yeah, here, right? So we don't need this. So this is the way you look Canvas. So here I think you have conferences, right? So it's going to be connected to conferences from 10 to noon, Tuesdays and Thursdays. So you can go and ask questions to her. We will talk a little bit more about Canvas, but let's keep going. Then see announcement, right? So I have a bunch of announcements, but I'll tell you at the next. So this is the teaching team. This is me, right? I am from Mexico, so I have a thick Mexican accent. Well, the textbook. So this is the first time that we are going to use in this class the third edition of this book by Alan Agresti, Introduction to Categorical Data Analysis. So, well, we are having a transition from the second to the third edition. So the notes are kind of, I'm updating the notes from the second to the third edition. And also, so this is the main text, right? And you can just look for it here. I have it in. This is the book, right? So now you have to be careful. It has to be the third edition, right? Well, so this is the book, and the other book that we're going. This is the main book. This is the main textbook, but we are going to cover some few chapters of the other book. That it is. I thought it's here, right? Applied Logistic Regression by David Hosmer and all these authors, right? But here, this is not the main textbook. Okay. So again, just be careful when you buy this book that it is if you or rent the book, it is a third edition, right? Okay. Obviously, this one is wrong because it's not a reference book. It is the main textbook. Well, just so you know, we have access online to the second edition of the book. I hope that we have access to the third edition soon. Well, we have access to this book, right? The second book. Well, and also be careful because there are two books, right? There's Categorical Data Analysis and Introduction to Categorical Data Analysis by the same author, right? So we're using the introduction to Categorical Data Analysis. Don't buy Categorical Data Analysis, right? And buy the third edition, not the second, but the third edition. So this one, right? There is the same author has two very important categorical data analysis books, but we want the introduction. Well, supported statistical software. I myself am way more familiar with R than with this data. So most of the questions that you have about this data, try to reach the TA. He knows this data way better than me. And we will an R code. Also, the third edition of the book has a lot of. Once they teach you a method, they show you how to apply the method using R. Well, you know, try to use the most updated version of the Stata that I think it's Stata 16, but 13 works if you bought it 1 or 2 years ago to take 1700, right? Intermediate biostatistics. There is a way to use, so R is free, right? So you don't, if you are willing to use R is free. And if you are going to use Stata, well, you have to pay for it or use the virtual lab, right? But again, if you took 1700, you know how to use the virtual lab to use Stata. Other statistical software, again, what we are going to learn in this class is very standard. Almost any statistical software can fit the models or apply the methods to the data that we are going to learn. So you can use, you are free to use SAS if you are familiar with SAS or with SPSS. The only thing is we won't be able to help you, right? We won't support that. Like, we will take your homeworks and if the answer is correct, right, you get all the points. But if you get stuck with the code or anything, we won't be able to help. So you can use any software that you want, but the only ones that are going to be supported are R, that it is open source and free, or Stata. Well, the communication channel is, again, Canvas mainly, right? So the modules are generally weekly, and lectures within modules will be posted on Canvas before classes. Like these slides are already posted on Canvas on the modules tag. Well, I'm always correcting for typos, right? Like probably you will find typos while I teach the class. Then I will go and correct the typos, and so if you download the class 3 or 4 days before the class, I mean the slides, well, there may be little changes. Nothing really important, but yeah, some little changes. So just keep regularly getting to Canvas to find course-related information, right? Like if I need to make an announcement, if I have to cancel a class, if I have if a homework got extended, or if I have a question that it is very good that somebody asked me, I will share with you guys. So again, use the discussion board, right, to discuss homeworks and course questions. That is, you can discuss that with your classmates. we don't have to be there, right? So maybe another classmate has any hints or something to help you with the homework. So assignments and grading, well, first the whole course is going to be 40% assignments, 30% the midterm, and 30% a final project. The final project is going to be teams, right? So you will have teams of 3 or 4, and you're going to find a data set that you want to analyze, maybe a data set that you are working with in your research, and you're going to describe the data set and explain to me how you analyze, the objectives of your hypothesis or the objectives when you analyze this data set, apply some methods that we learn in class or methods that we didn't learn in class but are useful. Like, of course, your data has to be categorical, right? The response or something has to be categorical, so it is material related with the class. The final grades are just with letters, right? From 90 to 100 is an A. From 80 to below 90 is a B. From 70 to below 80 is a C, and below 70, right? 699.99999 is an F. Okay, so the homeworks assignments will be posted on Canvas, and our completed assignments will be handed in class upon completion. Right? So you expect around 8 homeworks for this class, 7 or 8 homeworks. Right? And remember, the homeworks are 40% of your final grade. So that means that if we have 8 homeworks, maybe 7, every homework is 5% of your final grades, right? So the homeworks are very important. Like there is no way for you to pass the course if you don't turn in your homeworks. Policy of late submission, well, we will reduce 10% of the per given homework for each day delayed, right? So if you got 100, but you were delayed 1 day, you will get 90 instead of 100, right? And if you delay 2 days, then it's an 80, right? And so on. Late exams, by late, it's just a midterm, right? We will have only 1 exam, and it is the midterm. And well, obviously, they will not be allowed. And there are no makeup exams. I will give you the date of the midterm in a couple of minutes, and just make sure that you have that day to take the test. Students are encouraged to discuss homework with their peers, but they must write the reports independently. I already had said that. And well, if, for example, you send this is very common. 2 people do well, not very common, but it happens, right? 2 people work together, but they just write one person writes the answers, and sometimes they even send the same file, right? I have no choice but to pass that to student affairs, and well, they take over there. They will contact you and ask you what happened, and they make the decision. So please write your own report, right? Even if you work together with another person to do the homework. We don't want to have the exact same words, right? Well, the ethical issue is the same, right? We don't want plagiarism, right? Like if you find a project, if you're copy pasting from a paper or something like that, you will get into trouble. Okay, so the summary is, well, we're here to help you, I and the TA. I hope to make your experience in learning valuable and memorable. The material that you are going to learn in this class, if you end up working on analyzing data or to understand data, medical data, or from public health, you will use it. These are very basic concepts, right? So it's going to be a very useful class for you. Of course, if you end up becoming a politician, maybe not. But if you keep this track, then it is going to be very useful information. Also, now I'm going to jump to this is Canvas. Let me see if I can make these letters bigger. That's not big. So this is the course on Canvas. Here is where obviously you know because you are here. That's the way to join me, right? For the class. Here is the syllabus with all the information. That is essentially, I just gave you a summary of the information that is in the syllabus. This is the file. The midterm, so for you to say the date, is Thursday, March the 4th, obviously 2021. So now you know when the date is, right? So you have to keep that date. The grading weights, again, it is 40% assignments. So the assignments are very important. 30% the midterm, that it is going to take place on Thursday, March the 4th. And the final project that it is going to be at the end of the course. The classroom, I don't know if it matters right now, but the classroom is in the School of Public Health building, RAS 102A. It's in the first floor. But right now I can see it. I can see if there were students, I would be able to see. You can go. It is being forecasted there right now. The class is being forecasted there right now. Of course, there is nobody. I can see that the room is empty, but well, we end up going back to class. That I doubt it, but that is going to be the classroom, right? Or if you, for some reason, want to take the class from the school, this is the classroom. Here also under the syllabus, I have the tentative schedules, right? So the course is 17 weeks, actually 16 weeks, because we have spring break. So it is 17 weeks of class. So it is 16 weeks. It is the tentative schedule, right? It depends on how many questions you ask or if there is delays, right? But this is the tentative schedule per week. So we have 16 weeks. Also, just so you know, here are the weeks. This is the material that we are going to cover each week. And well, just so you know, week one is this week, the current week, right? From Monday, January 11 to Friday, January 15, and so on, right? Also, if you'll see that the class is not good for you, like maybe too hard, or this is not what you expected, you can always drop the class, right? It is January the 27th is the last day for you to drop the class for non-payment, right? Yeah. So the class didn't have here are some other important dates. They don't really affect us because the class is Tuesdays and Thursday, but we have Martin Luther King and President's Day, right? That the university is going to be closed. I mean, for this class, it doesn't matter because, well, we are not teaching on Monday. We have the spring break. We have this important day too, that it is, you are going to give me your final project proposal. Again, this is going to be a project where you are going to work on teams. So you can start looking for teammates. So at the end, if you don't have teammates, I will find somebody for you. April 30th is the last day of class, so the last week, and this is when you are going to present your proposal presentations. You will have to give me a written. You will have to give me your project, a written version of your project, but you will also present what you did, right, on your project. That's going to be the last week of classes and the week of the finals, right? And you are going to grade your own classmates in the project. Okay, what else? Oh, we will have quizzes. Right now there is a quiz, but I will post the quizzes before a certain topic for you to take the quiz. The quiz has no value; it will not be graded, but it is a good way to test if you are reading, if you are understanding the material that it is being assigned to read before class. Right. I mean, again, it's just for you to self-evaluate yourself, right, and your progress with the quizzes. So it is very nice if you take the quizzes. There is right now no quiz. What else? Here's the syllabus. Yeah, okay. So you can see here announcement. Oh, the announcements. So here I have the first announcement, right? Well, obviously it's kind of a repetition. It is, Tuesdays and Thursdays is when the class is going to take place. I am using this WebEx room, my personal WebEx room provided by the university to teach this class. But you have the link, right? You can also just use the Canvas link to connect to the class, or you can use use WebEx and use this room, right? Also, you have questions, you want to meet with me. I don't have office hours, but you can always contact me through Canvas, and I will try to. I mean, if you want to meet with me, I will try to find a time to meet as soon as possible. And if we meet, it's going to be through my WebEx personal room, right? Here is the link. But again, there is a direct link on Canvas. You don't have to have this, but you have it now, right? The classroom again assigned is 102A. In case the class is switched to in person, I doubt it, but well, that is the class. The class is transmitted there right now, right? And it's kind of a waste of electricity. Oh, now I see somebody in the 102A, but
Just IT taking a look.
But it's not a student, right?
Correct.
Yeah. Okay. So, well, just monitor Canvas, right? Important notes again. This is the book, the Introduction to Categorical Data Analysis by Alan Agresti. It just came out late 2019. The course was developed using the second edition, but we are making the transition this semester, right? Class attendance is required. I receive a lot of emails per day. Use Canvas if you want faster replies. Well, I already gave you the grade breakdown, right? That it is 40%. Well, everything, right? The syllabus is posted here. Sorry, on the syllabus tag. We already talked about this. This is very important. Midterm will be March the 4th, right? There is a typo here, but it's March 4th, right? So the final project, right? So the final is a group project, probably of 4 people, and it consists of a written report, like a journal article, and a presentation of data analysis for a real-world data set that you will identify, right? Again, teams of 3 or 4 people, and you will use. I mean, if you have data set around that data set that belongs to you or to the people you are working for, and they are willing for you to use it in the class, that's better, right? If not, but you can always get other data sets from online. So the project presentations will take the last 2 weeks, right? So this April 27 and April 29 are the last week of classes, and May 4 is the first Tuesday of finals, right? For the final week. And if necessary, so this is like baseball, right? Like the 5th game if necessary, right? May 6. You will grade each group per review, and that will account 20% of of each group's score. This is each one of the other each other people are going to grade you. Obviously, that is not in the team, and that will count, right? So the TA has 4 total office hours per week, right? So she has 2 slots of 2 office hours again, AM to noon. Also, it's very important, right? Because some of you may work at that time or maybe have taken classes or anything. So it's going to, once you contact her that you cannot do it at this time, you can schedule another time to meet with her. Like for example, for us, for homework, like if you have questions, you think she's the grader of the assignment, right? I think it is better that you go with her, right? Before you come with me. If you think something was right, but you didn't get full credit, you can go with her and all that stuff. So I will stay, I mean, usually I will stay after class, right? If you have questions, but I can also hold office hours by appointment. Just let me know and I will try to make it work as soon as possible. All right, so this is, so remember, March 4th is the midterm. Here is the syllabus, and well, we have this. Here you have the weeks, the week dates, right? You have the quizzes are going to be posted on the model. So right now there is no quiz. If there were a quiz, we would have it here, right? Quiz 1 or quiz 2 or quiz 3. Well, obviously this is software, you don't require it right now. Well, you have any questions? And if you don't, I will start with the first first chapter of the book. No? Okay. Remember, grading is 30, 30, 30, 40, where 40 is the homeworks. Okay. Well, if you don't have questions, I will start talking about the chapter 1 on the textbook, right? Yeah, this stuff that has nothing to do with the class. I was working with chapter 2, but that's not the 101. Okay. So again, this is I actually think you can probably see the first chapter of this book online, right? If you don't have the book yet. So this is again the material in the first chapter of the Agresti book, Introduction to this book, right? Introduction to Categorical Data Analysis, 3rd edition. And remember, 3rd edition is very important. So this is the outline of the first chapter, right? We will give some examples of categorical data, commonly used distributions to model categorical data, that these are the binomial, the Poisson, the negative binomial, and the multinomial distribution. We'll just give a brief introduction of what the maximum likelihood estimation is. And then I'm going to give a light introduction of statistical inference for categorical data. I'm going to talk about the three types of very generic tests. And by generic, it means that I can essentially use them for any statistical test that I want to perform. So one is the likelihood ratio test, there is a word test, and the score test. Just very light introduction, so you have an idea what this is. So the motivating examples, well, this is a clinical trial, right? The clinical trials are used to compare treatment and placebo, right? Because right now it is very common, right, to hear clinical trials because the vaccines, right? The COVID-19 vaccines results for the clinical trials are public and available, right? So out of 15,000 people that received the placebo and 1,000 people that received the vaccine, how many got COVID, right? So, well, but when this is a clinical trial in traumatic brain injury, and we have two arms, right? This is just the arms is the group of people who receive the treatment. That's one arm, and the other arm is the group of people that receive a controlled treatment, right? And the outcome is measured by, for example, a 6-month Glasgow outcome scale, right? So it is, if the scale is dichotomized, right? So it can be, for example, favorable outcome. So that could be good recovery and moderate disability, or unfavorable outcome, right? Severe disability, vegetative state, and death. Right. So right now, again, with the COVID-19 vaccine, the outcome is the person developed COVID at some point during the first 3 months, I think, versus the person did not develop COVID, right? Well, we have two arms, right? We have the people who received the vaccine and the people who received a placebo, right? And of course, you want to split the population 50-50. So what are some methods to compare the two arms, right? So for example, in a clinical trial, when you have a dichotomic response, how am I going to know if the drug or if the treatment has an effect or not, right? And the other is, what if you want to adjust how severe the injury was at base? You need methods to do that. Because different people, in this particular example of traumatic brain injury, the level of injury is different, right? So you may want to adjust for how severe the injury was in your analysis, right? Another example, well, again, this is the West African Ebola. So they administered a new treatment to 6 people, and 2 of them subsequently died. So this example is very small, right? So 6 people received the treatment, and 2 of them died. So is that enough to say that the treatment is good, that the treatment has any positive effect on the survival or not, right? So it is 2 out of 6. So here we're just saying that, and you can see they say that the null hypothesis, right, for the people who know, is P, the probability of death, right? 0.55, right? And if the treatment has no effect, right? Treatment has effect, we're going to see that P is lower, right? So this is actually. So strictly speaking, the null hypothesis is this one, right? But you just go 2 out of 6, right? So you 2 out of 6. Well, that's the question, right? We don't have to. This is just a motivating. So how much evidence that this treatment is effective, right, compared to the standard of care? So the standard of care gives you 55% mortality rate, fatality rate. What type of method could you employ to do this analysis? Well, if you took intermediate biostatistics, kind of figured it out, right? But what if you want to, like this one, it just a binomial test, right? But if you want to adjust for the quality of the healthcare facility, severity of disease, and other important coverage, then this becomes a little bit more complex, right? If you remember intermediate biostatistics, this is just a binomial test. But then once you want to control that changes. So this is categorical data analysis, right? So we need to define or remind you what a categorical variable is. So the variables, so this is just what you measure of the individual, right? Or what you're measuring now from patients, right? So variables are typically defined as either continuous or discrete, right? Continuous variables assume any value between a minimum and a maximum. For example, it can be the blood pressure, the temperature of the person, I mean, the age, right? If you measure in base product, right? And this is a finite, or at most countable, right? Number of values. So for the people, countable just means that you can, this is countable, right? So it can be infinite, but it has to be, you have to be able to map it to 0, 1, 2, 3, 4, 5, and so on, right? So the discrete variables can be ordinal or categorical, right? Ordinal means an order, right? That you can set an order on the variables. Categorical means that you don't necessarily can set an order into a natural order, right? Actually, to be more specific, usually you call this type of variable nominal, right? Just comes nom. The only thing you can do is to name it, right? That's nominal or polytomos, right? So you have ordinal, and I like the word nominal better, right? Or nominal, right? Nominal is you can just name the categories too. Ordinal, you can order the categories. Nominal, you can just name the categories, right? So ordinal variables take a limited number of values or categories, and the categories are ordered, right? So for example, the socioeconomic status, right? Lower socioeconomic status, lower to middle, upper middle, and upper socioeconomic status. There is a natural order, right? You can say that this one is lower, smaller than this one, smaller than this one. So this is the order, right? Or the other way around, but there is an order, right? Likert measurements in psychology, right? These are on behavioral science. Usually they ask you, one example is don't agree at all, right? Disagree. So this is a Likert. Disagree, completely disagree, right? Then the other one would be slightly disagree, right? Or just disagree. Somehow disagree, right? The other is neutral. Somehow agree and agree, right? That is an example of a Likert scale. And of course, there is an order, right? And when you categorize the age, right? So this is, you said different groups. 0 to 20 is lower than 20, it's younger than 21 to 40, younger than 41 to 60. So there is a natural order, right? So those variables are called ordinal variables, right? And the other categorical variables take on a limited number of categories with no inherent ordering, right? So the hospital type, for example, there is no order, right? Teaching and non-teaching. Two types of hospitals, one where they have what they teach and some where they don't teach. So there is no order, right? Sex, male and female, there is no order. Geographic area, there is no order. I don't know, can you think of any other categorical variable? Race ethnicity is very common, right? In the analysis, race, ethnicity. Here in the ordinal variables, the education level is also very common, right? We have high school, usually high school, some college, right? This is what I have seen in my experience, right? College. Here it starts getting complicated because then you have college and other stuff, right? Masters or just post graduate education, right? This is very common to take into account these variables in the analysis, right? Race, ethnicity, gender. Another one very common is marital status, right? Single, are divorced. No? So you analyze data for patients. All this is very common. So when making inference about discrete variables, we consider the proportion of subjects in each response category, right? So again, if you have categorical variable, the only real thing you can do is to count, right? How you have your sample with 100 people. The way to summarize gender is to count, right? How many are male and how many are female, as opposed to when you have continuous variable that you usually use the mean and the standard deviation, right? So what we actually care is going to be to make analysis when the response is categorical, right? Okay. So we will learn in this course to analyze data when we want response or outcome to be a categorical variable, right? So it's going to be statistical inference for outcomes for response variables or dependent variables, right? You remember regression. In a regression, you have y equal to beta 0 plus beta 1 x plus an error, right? This is simple linear regression, right? So this is your response or outcome, right? Just many names, right? Or well, dependent variable, right? I don't like this one, but dependent variable is also a name. So for example, if you, the classic example is how tall the person is, right? And this is how tall the father is, right? It's a classic example in textbooks. So this is how tall father is, right? And this is how tall you are, right? Son is. Right, so this is the dependent variable, right? Because I am trying to explain y with x, right? So this is the dependent. Or we also call it a predictor, right? Because you are trying to use this to predict. Well, but this is linear regression. In linear regression, you assume that you remember that the errors are normal distributed, right? And IID. So that means that this variable is continuous, right? Because y is normal. So this variable in linear regression, this is continuous, right? So in this class, we will change y, right? Y is going to stop being continuous. It's going to be a categorical variable, right? So this is in linear regression, but this is not this class, right? For that, you have other classes. There is a linear models class, or you also learn this in intermediate biostatistics. So here, my response is going to be categorical, right? So the new game is that y, my outcome variable, is going to be discrete, right? Or categorical, or even ordinal sometimes, right? And the class offers some examples of categorical variables. Well, the classic example is y 0 or 1, right? 0 if the drug is not effective, right? The person, not the drug, but 0 if the person got worse or something, right? In a clinical trial. Well, now we have the very, again, y is, I'm trying to find the razors. 90%, okay. So in a clinical trial of COVID, right, that it is the trending topic right now, is we have y, no point here. So yi, right? So yi, so you will have 0 if the person developed COVID in the first 3 months, right? Sorry, did not. It's a 3 months. And 1 if the person does, right? So just yes or no, right? It could be 0, 1, or yes or no, right? Yi. And your xi, well, your explanatory variables would be, again, you can have 0, 1, or yes or no, right? 0 if the person received placebo, right? And 1 if the person actually received the vaccine, right? I mean, obviously, they all got vaccinated, right? With an injection. One was just placebo and the other was. So the person doesn't know if they have placebo or vaccine, right? So the explanatory variables, also called predictors, covariates, are the independent variables, right? So this one, obviously, here, the independent variable would be xi, can be discrete, continuous, or both, right? So, well, what matters for our techniques is that the techniques that we are going to learn in this class is when the response is categorical, right? So we don't care about xi may be continuous or discrete, but yi is, has to be categorical, right? The response. Well, of course, it depends on the context of the problem, but for example, here, so they say you these 3 variables, right? Which one is the you think is going to be the response variable, and which ones are predictors? Somebody tell me here, which one is the response? Which one you think you would use to predict the others? Which ones would you use to predict the remaining one? It depends on the context of the problem, right? All right. Tell me. Okay, I'll do the first one. I think it's kind of clear, but it can I mean, there is no clear answer. You can always find a way to. Okay, we have a volunteer. Let me see. I won't. Okay, here. Trying to find the text. Oh, here. Well, this one is small. Okay, so I'm sharing the screen. Okay. Here is chat, right? Okay, so I have somebody, I won't tell the name. I guess probably public, right? Okay. So gender and education predict, yeah, that's a good one, right? I mean, of course, you can always find, but attitude to work, if you are interested in attitude to work on control, favor, or oppose, maybe you think that gender and mother's education will have an effect, right, on that. And the other one is heart disease. Oh, yeah, response variable, attitude to work on control. That's correct, right? Here, I mean, again, depends, right? But usually you think that heart disease, right, would be the response, right? Well, it could be the other way around, right? But in this particular case, it has to be, if we want to use our techniques learned in this class, this has to be the response, right? Because that's the only categorical variable, the heart disease, yes or no. But of course, there could be a context where you want to know if cholesterol is higher in people who has a heart disease and blood pressure, then cholesterol is going to be your response. But well, just keep it simple. Heart disease is the one, right? Now here. So which one do you think you would want to predict? I mean, right now it is with all these elections and everything, I think you usually want to use everything to predict the vote for president, right? So the response is going to be a vote for president, right? So now you have three categories instead of one, right? You have 1, 2, and 3 categories: Democrat, Republican, or other. And we hypothesize that we have this, that the race, the religion, and the annual income may be associated. Okay, but yeah, exactly. Vote for president response. Yeah, that's correct. Okay, final guess here. Which one? This is a hard one, right? I think the response would be here quality of life, right? So here you want to know if the, yeah, good. I'm getting good answers. Yeah, quality of life is the response, right? And marital status is the, again, you can always find a context where you can flip the variable, right? You can say, oh, I mean, I can think of one with quality of life, but I can think of, do Republicans tend to be Catholics? Then that changed the question, right? Instead of do Catholics tend to vote Republican, right? So here, which scales of measurement is most appropriate for the following variables, nominal or ordinal? Political party of affiliation, is that nominal or ordinal? Well, is there an order? It's nominal, there is no order. You are correct. Thank you for answering. The highest degree obtained, well, when you highest, we are thinking of an order, right? Lower, higher. This one has to be ordinal, right? Because it's non-high school. This is very common when you analyze data on patients, right? Patient condition, obviously, this one is also ordinal, right? Yes, thank you. How often you feel depressed? This is the Likert scale we were talking about, right? Likert. This is actually a name. Then you can go online. I may be mispronouncing it. It's like, I don't like or Likert, something like this is a name. So he's the guy who came with this scale in psychology, and now it is called Likert scale, right? But it is just stuff like this, right? In survey data, right? Or in questionnaires, in psychological questionnaires. Just Google. This is a name. And so it's hard to pronounce because, well, it is pronounced the way the person's last name was pronounced. Well, so the common use probability distribution used for categorical data, well, you know, if it is 0, 1, the response is nominal. Sorry, yeah, it has just two values. What is the only distribution that takes either 0 or 1, right? So Y is either 0 if the person, again, 0 if no COVID, and 1 if COVID, right? So then Y has to be Bernoulli, right? There is no other chance. The success probability, and well, that's what we want to know, right? Okay. So for discrete data, continuous data, we have to make assumptions about the probability distributions of the response variable, right? So recall that when we have continuous responses, like you did before, we perform student t-test, right? Or fit a linear regression model. In either way, you were assuming when you were applying the student t-test or you were assuming that the data is normally distributed, right? Gaussian or Gaussian normal bell curve distributed is the same thing, right? And they play, well, and distributions play a central role in statistics, right? So what if you have categorical responses, right? So we will focus on 4 main distributions to make inference. One is binomial distribution, that of course the Bernoulli is a particular case, right? Bernoulli, remember, Bernoulli is the distribution for variables that take only 2 values, right? Well, we label these values as success or failure, or 0 or 1, right? Binomial is the number of successes in n trials. We will talk about that. The multinomial distribution, where you have more than 2 categories. Hypergeometric distribution, we will talk about that, but that is, we will talk about that. The Poisson distribution, this is very important because this one is for counts, right? We want to model usually counts. So remember, a variable that is counts is also discrete. It can take an infinite number of values, but they are counts, right? So for example, the number of COVID patients that are reported in Houston area, right, every day could be Poisson distributed, right? Of course, we need to model the parameters of this Poisson distribution. And well, the chi-square distribution is a continuous distribution, right? So this is not really, but it is very useful because a lot of asymptotic results, just like we had with linear regression, the chi-square distribution will play a role. So binomial distribution is, yeah. So these are the 5 main distributions. The binomial distribution is the one that we will use the most. Well, so let's start with this. So we start with binomial distribution. I know you already learned this in intermediate biostatistics and probably in many other classes, but just let me remind you. So when one variable has only 2 possible outcomes for each trial, so here is where we have, remember, a Bernoulli trial. It's an experiment, right? That can have only 2 possible outcomes. And those outcomes are flagged as success. And again, whatever success means, and failure, right? And usually the failure is also called as 0, and the success is called as 1, right? So a Bernoulli trial, again, tossing a coin, right? That's the most common example of a Bernoulli trial, is to toss a coin. So you say Y is 0 if heads, right? So that's a failure. Head is a failure just by the definition of 0 failure, right? And 1 if the other one, right? Non-head, but in this particular case is heads and tails, right? But that could be, that is the, and then of course you define this probability by defining the probability Y equal to 1, right? So this is a random variable. This is just the probability of observing a tail, right? In this particular case, if the coin is fair and etc., this is 1/2, right? So that means that Y is Bernoulli with success probability 1/2, right? So this is the parameter of my distribution, right? Okay, so that is a Bernoulli trial or just a trial, right? So if we have any independent and identical trials, right? So again, if I toss the coin, or if I toss 10 coins, right? The result from, so this is very important, the result from each trial does not affect the result from another, right? So if I'm going to toss 10 coins, right? The result of the first coin will not affect the result of the second coin, right? And the probability of success is the same for each trial, right? So the probability of success of each one of my coins is 1/2. So we call pi the probability of success, right? So this is pi, the Greek letter pi, is the probability of success. Well, in my coins, it's 1/2, right? And so now, of course, pi is going to be, in a clinical trial, is going to be the success rate of the treatment and the success rate of the placebo, right? Well, so this is, once we have Bernoulli, right, defined like this way, if you remember the definition of a binomial is the sum of Bernoulli trials, right? So if I have y1, y2, all the way to yn, just remember, this one, each one is 0 or 1, right? So this is 0 or 1. So for example, if I have tail, head, tail, right? So let's play. That means n is equal to 5, right? I have 5 Bernoulli trials. Let's say this was my outcome, right? So tail is 1, 1, 0, 0, 3, right? So, and then I define y. This is capital Y without subindex, right? As the sum of the yi's, right? So in that particular case, my y. So y1 is equal to 1, y2 is equal to 1, y3 is equal to 0, 0, 1, right? So y, the sum of the yi's is going to be equal to 1, 2, 3, right? Is the number of successes out of n trials, right? In this particular run, y was equal to 3. And then we write that the distribution of y is binomial and it has two parameters. N, that is the number of trials, right? In this particular case, it was 5. And pi, that is the success probability. In this particular case, if the coin is fair, pi is equal to 0.5, right? And well, as you remember, this is the probability mass function of the binomial distribution, right? So this is just combinatorics, right? And it's pi to the y, 1 minus pi to the n minus y. So also you remember, and if you don't, you can always go to Wikipedia and see that the y, remember y is binomial and pi, expected value y. So how many here? If I don't tell you, of course, if I don't tell you this, right? If I haven't run the experiment, if I haven't run, if I haven't tossed the 5 coins, right? What is the number of heads that you expect? Well, I know that to know, right? But I know that if I'm going to 5, so think of 5 coins, and the probability of head is the probability of tail, right? That the success is 1/2, right? The question is, do I expect more tails or more heads? I mean, there is no reason to expect more heads, right, than more tails, and there is no reason to expect more tails than heads. So it has to be something in the middle, right? So it has to be 2.5. Well, anyway, all this to the expected value of y is n, the number of trials, and pi, right? This is the expected number of successes, right, that you expect in your that you expect, right? So it's 2.5. In this particular case, it could be just, my example is going to be n is equal to 5 times 0.5, that it is a coin. So that's 2.5, right? And it's kind of, should be kind of intuitive, right? The variance may not be as intuitive, but it is given by this, right? So in this particular case, it would be 5 times 0.5 times 1 minus 0.5, right? So 1 minus 0.5. And this is equal to 5 times 0.25. I think it's 1.25, right? But so this is the super famous binomial distribution, right? And well, you can play with it here. Let me see. You see, this is the, so for example, if number of trials, so it was equal to 5, right? So this is the probability of 0 heads, assuming tail, right? It was tail. Tail was the success, right? In my example, this is the probability of getting 0 tails is given by this. The probability of getting 1 tail is given by this. The probability of getting 2 tails is equal to the probability of getting 3 tails. And it's kind of symmetric, right? But you can play, right? If you have 10 coins instead of, you can do it here, right? It's again symmetric, right? Because the probability is the same. So the probability of having three heads should be the same as the probability of having 3 tails. So 3 heads, and if it is n equal to 10, 3 heads is equal to 7 heads, right? So 3 heads. But then you can change the probabilities, right? So imagine you have an unfair coin, right? So the probability of tails is 0.8. Then it changes everything, right? You expect way more heads, right? So this is obviously a representation of the the probability mass function of the binomial distribution, right? With these two parameters, n, the number of trials, and p, the success rate, right? Okay. So of course, that is, the binomial is very good when, or the Bernoulli is very good model when your response has only 2 possible values, right? Also a fancy word I think they use for 2 values is, I think, dichotomous or dichotomic. That means the variable take 2 values, right? So let me see if it is, let me see, how do you spell the, I'm just trying to see how to spell dichotomous, right? Yeah, it's dichotomous. Dichotomous. Okay. So this is the word, right? Sometimes you will see that fancy word, right? To just, the only thing that they are telling you is a dichotomous variable just means takes 2 values, 0 or 1, right? Okay. But of course, what if you have more than 2 possible outcomes, right? Y could be, for example, if Y is the outcome for a driver in a well, you may have not only injured, right? You have uninjured, right? Injury, but not requiring hospitalization, injury requiring hospitalization or fatality, right? So then your response is not dichotomous, yeah? Also, if the trials are independent with the same category probabilities for each trial, then we can use, so you see, this is the same, right? The other is binomial. So the only thing that we are changing here is the name, right? For B. B is 2, right? 2 categories for multinomial. And and by the way, I am trying to follow the book. So this is between square brackets just means this is the section, chapter 1, section 2, subsection 2, right? 1.2, and that's the way it's written in the book, right? Where we are. So this is also hopefully a reminder of the multinomial distribution, and if not, well, you can always find more about it on the Wikipedia, but the idea is, well, here, right? For example, y. So let's say y1. Now it's going to be a vector, right? Because I have only one entry is going to be, so I have 4, right? 1, 2, 3, yeah. So if the person got injured, uninjured, right? So this is this is uninjured. Then this is 1, and all the other entries are 0, right? Yep. And then that's the first person, right? Another person who had an accident, but well, this person now got injured, but the person did not require hospitalization, right? So I will just, this would be just a 0 and 1. So whatever happens, just a 1, right? Y3 is a person. So remember, this second column is is the flag of injury non-hospitalization, right? So another person, for example, had it required hospitalization, right? Well, and you to keep going with your data set, right? So you have Y 200, say, right? 200 people, and this last person, unfortunately, this person died, right? So this means the person died here, right? Okay. So now I'm going to sum all the Y's, right? So entry Y's, right? So Y is going to be the sum of the Yi's. Remember, these ones are vectors now, right? So this is just going to give me, it's going to be the number of people in my sample, right? That got uninjured, right? You're going to have 4 entries, right? The other is the number of people. So remember, I'm summing, right? 1 plus 0 plus 0 plus all the way plus 0, right? So I'm just counting the number of ones in this column, and that is going to be the number of uninjured people, right? And well, and you do the second entry is going to be the number of injury, but no hospital, right? No hospital. The other is going to be the third entry of my vectors is going to be the number of injury hospital. And the last one is going to be the number of fatalities, right? Well, so this Y is going to be, as we will see in the next class, is going to be multinomial distributed, right? Under certain assumptions. And well, here is where I will stop. If you have questions, I will stay here for a little bit. And if you don't, well, you're free to go. I will stop recording now. And well, I don't have the recording immediately after class. It takes like a couple of hours or sometimes next day. But as soon as I have the recording of the class, I will make it available for you. Just so you know, I think you can see the class here, right? I'm sure you know because you already took here, right? In Panopto recording, you will be able to see the class.
Professor.
Yes.
I registered for the class today. I was pretty late, so I'm still not on Canvas. Should I email you or the TA so I'll be on Canvas, or will it happen automatically?
I don't know, but you know something? Email me and I will add you.
Okay, thank you.
Email me right now and I will add you on Canvas.
Okay, thank you.
Okay. All right. You're welcome.
Thank you.
You're free to go, guys, if you don't have questions. I'm just saying, just in case somebody has questions.
Hi, Professor. I have a question.
Can you speak loud? Yes.
Hello, Professor. Can you hear me?
Yes, I can hear you. But you
Yeah,
are so-
I have a question about the data analysis. So that's actually related to a project I'm currently working on, and I would like to have some of your suggestions.
Oh, that's awesome. Yeah.
So, my outcome is the AUC, which is actually like a percentage of the cell response to some kind of drug. So that's like a percentage. So I was trying to like conduct a model on it, and I'm not sure like which model I should use.
I mean, the problem with, I mean, we're way too early in the class, but the problem with percentage, just like you are telling me right now, is that it's not categorical, right?
So yeah, it's not categorical. So it's actually it's like genetic data, and they put it on like cell, like some kind of medication. They put them on cell and count, like for example, each of the gene, like if they respond to the drug. So that's, and they count that number, and they just like divide it by the total population. So that's how the percentage comes out.
Oh, okay. So then you may be able to, I mean, I would have to look deeper into that, but you may be able to use to model the counts, right? Not the percentage, but the counts.
So the thing is, I don't know the total number. That's already like calculated by like someone else, and the only thing I have here is the percentage of response. So I'm not sure, like, yeah, and that's between 0 and 1, and I'm not sure which model I should use.
Yeah, I don't know if we're going to cover it, because that's not categorical then. It is continuous, right? I mean,
Yes, but that's between 0 and 1, and I'm not sure, because that comes from a count, and then it's like divided by the total. So
but you don't have the total, do you?
I don't. I was thinking about probably like, I think it's kind of like, I know logistic regression is either like 0 or 1, but like right here is like, it's such a number between 0 and 1, and when I go to see the distribution, like it's like, it's totally not normal. It's like most of the number is very close to 0, and then just some of those, like just some of those are like greater than 0.
I mean, again, I think the problem is you don't have the counts. That's very weird that you don't have the totals, because it's not the same that I tell you I found 1 out of 2, right? As one. So your percentage is 0.5. If I tell you whatever you are counting, I tell you 0.5, it's not the same if you have 1 out of 2 or 500 out of 1,000, right?
Yes.
So it's I don't understand how you could perform an analysis without having the totals, right?
Yes, the only thing I have is the percentage. So the outcome is basically percentage of the response, because they use like a lot of cell to repeat the experiment, and they just don't count the total cell. They have some way to calculate the percentage, but they just don't give the total number of the cell.
Okay, I mean, this may not help you too much, but I think what you usually would do, you have a number from 0 to 1, is to use the logic transformation. So you do log of that number. Like if your number is, call it pi. Let's you do pi divided by 1 minus pi.
Like a Box-Cox regression, like a Box-Cox transformation?
No, it's the logistic transformation, right? Log of pi divided by 1 minus pi.
So the thing is, when I talk, because that will just change the distribution, and we don't know like if the changes between the number is.
Look, do this. Transform your percentages, right? Do this.
Yes.
and try to apply something like not logistic, just like normal regression.
So is there any way like we just don't do any kind of transformation and just conduct some kind of
I mean, I don't know. This is kind of out of the scope of the class because it's not categorical. Once you have the counts, it is categorical, right?
Yes. Can
But
I?
if you have something that goes from 0 to 1 and you're having issues, but this is continuous, right? Because 0 to 1 is a continuous.
Okay.
When you do this, what you're just passing this to the real line, right?
Yes.
Then you apply linear regression. Not this is a regression problem once you do this. But what I am surprised again is that if you have pi equal to 0.5, right? Okay, 0.5. You don't know if this came from a set of counts that were 1 out of 2 or 500 out of 1,000, right?
Oh, we don't know. Correct.
And that's sad because this one really doesn't tell you too much, but this one tells you a lot, right?
Yeah, correct. Yeah,
Because 1 out of 2 is, doesn't tell you.
Yeah. Thank you. That helps a lot.
Oh, but I hope it helps. All right.
Yes. Thank you. Have a good one.
You
Bye.
too. Bye.